Good evening, friends. Welcome to Eastern Academy. And we are discussing about digital electronics as a part of embedded system programming class. And now we are discussing about the session 8, the last session of this digital electronics. And we're going to discuss about another very important component and fairly slightly confused for the people. Most of the students get confused about this part. This is about a part called ROM, read-only memory. Okay, so let us get to the board. And it's not as complicated as you think, but it's a very useful component. I'll tell you now what it is. So the trick here is, we know a tri-state. Am I right? We know a tri-state gate. I have a tri-state. Let me take only 4 bits, easy to understand. Instead of 8 bit, I take only 4 bit. Understand? I have a signal called enable. All the enables are connected. Let me do it the other side. So you understand, all the enables are connected. And this you call in 0, in 1, in 2, in 3. This you call D0, D1, D2, D3, assuming that. Now what I do here is, I connect this wire to pull up. I connect this wire to pull down. I connect this wire to 5 volt ground. If I give enable signal, what happens? Let me know. If I give enable signal, what happens? If I give enable is 1, what happens now? Anybody, please? Please, I want an answer. If I give enable is equal to 1, what happens? Try to understand. I0 is connected to 5 volt. This is connected to ground. This is connected to 5 volt. This is connected to 5 volt. I make enable as a 1 now. What happens now? When enable is 1, these are connected. Am I right? These are connected. Here internally, what is the voltage? 5 volt, because it's connected to 5 volt. This is 5 voltage is 1, 0, 1, 1. You get here 1, 0, 1, 1. Am I right? And if I put this inside a package, if you put inside the package everything, if you give enable signal, I get this data. I cannot change it. I cannot write, because these connections are already made. That's why they call this as a read only memory. This is called ROM. The problem is, even you don't give a power, this guy will be there as such, because this is a permanent connection. That's why this is called non-volatile memory. Understand now? This is called non-volatile memory or read-only memory. The other one is called read-write memory or RAM. This is called read-only memory. I'll explain to you in a few minutes why that is called this one. The same thing instead of 8, 4. If you have a 8 internally, if you have a 8, 1, 2, 3, 4, 5, 6, 7, 8. This is D0, D1, D2, D3, D4, D5, D6, D7. The beauty is you can decide what data you want. Oh, I want to store 10110001. This is MSB. This is LSB. So you want this to be 1, this to be 0, this to be 1, 1, 0, 0, 1, 1 you want to store. Wherever you want to take 1, you take it out. Take here like this, longer one. And connect everything. I connect everything through the wire. And connect it to 5 volt. Okay. Now, not 5 volt, connect it out. You're going to give a supply outside. 5 volt. Now, same way, this wires connect all the 3. Give it out. This you are going to ground it. For example, you don't give the supply here. If you don't give a supply, nothing will happen to the chip. You remove the pen drive from your laptop. You remove the SD card, micro SD card from your mobile phone. The data is there permanently. That's why it's called, that is called non-volatile memory. That is nothing but inside is in your SD card and everything is you have only ROM. But how do we write? I'll tell you later. How do we write now? So you understand now. That is, so you cannot make the connection. This is inside the IC. You cannot make it. So you have to tell the manufacturer, you should give the manufacturer, I want to store 10110011. The manufacturer will make the IC and give it to you. Understand now? You cannot change it. That's why they call this as a read-only memory. You cannot change the data. And they have changed the name of the signal, enable to read. So if I draw this as a small block, if I draw this as a small block, I have a block which has data, 8 wires, data, and they have a read. That's it. What is stored here is not, it's not changeable. It's who has stored it? The manufacturing company. And you have a call read. Let us say you want to have 2 locations. You want to store 2 data, 65 and 45. Then read data. This is called read 1. This is called read 0. And data is data only. All are connected. Same way, I can have any number. As I mentioned previously, if let's say I have a 4 block, read 2. The only thing is write is not there. That's the only thing. The only write is not there. D. I have 4 blocks. I have 4 combinational blocks. 0, 0, 0, 1, 1, 0, 1, 1. And I have a signal called 2 signals, A, 2. This goes to all of them. This is called select 0. This is called select 1. This is called select 2. This is called select 3. Same for the RAM. And here I have once again AND gate. And this goes to read. And here also AND gate. This goes to read. This could be 41, 78, whatever could be. This is called 4-byte ROM. Why it is called ROM? You cannot change the data. Who gives you the data? This data is written by the manufacturer. You cannot change it. You cannot change it. That's a problem. That's why it's called non-volatile. Even if you remove the power, the data will be there. This will be very useful when you are discussing about the microprocessor. All the computer, your mobile phone, your computer, your embedded system, all the systems with the microprocessor where you are used, you need to use the ROM. ROM is a very, very critical component of the system. Now, let us erase this. I have a chip. I have a data address. I have a read. And I have a data. Data is only out. This data cannot go inside because this is ROM. Okay. And the address could be any size. If you have a 20 means 2 power 20. So 10 means 2 power 10. 1K kilobyte. If it is 20 address line means 2 power 20. 1 megabyte. If it is 30 means 2 power 30. 1 gigabyte. So that's the way your sizes are going to be changed. Understand now? And there's only one signal called read. You don't have a write signal. Please understand, ROMs don't have a write signal. But every time you cannot go to the manufacturer and do this. For that reason only, they have given a provision here for you to change it. For that, forget about this right now. Right now, forget about it. I told you we have a tri-state logic here. We have a tri-state logic, 8. That all goes here. Sorry, data. And here we connect them to 5 volt or ground. But there the engineers did a good thing. They had made this a small block here inside the IC, which you can give a signal from outside and change the switches. For that, they use a transistor called FG MOSFET. I don't want to confuse now. I just tell you the only thing. FG MOSFET. That's called floating gate metal oxide semiconductor field effect transistor. See that? FG MOS. That's a technology. They used it internally such a way you can do that thing. There are so many methods. The first thing came into the market was PROM, programmable read-only memory. That means that you can make what they have done was the resistors. I'll tell you one thing here. You have a tri-state. There's a resistor. See that? They have 2 resistors. One is at ground, one is at 5 volt. Understand? There is a fuse. Another one. Same thing. For everything, there are 2 resistors with a fuse. If you want this to be 1, this bit, then you remove this fuse. If you want this bit to be 0, you remove this fuse. That's why they call this operation as a program. How do you do that? You cannot simply do that. You have to take the chip and put it inside the programmer device. And they give us, see, this side will be same. See that? Address, read, and data. That is same. But they use some other signal and they change the data. But once you change it, that will be permanent. The moment you remove the fuse, that will be permanent. Still, it is the PROM is also a ROM. It's a non-volatile. But the beauty is when the company gives you, okay, they allow you to change the fuse, cut the fuse. Am I right? They allow you to cut the fuse. That's the thing they have done it. But then they thought, how do I, let's say I bought a chip. Okay, it's called blank. See, you see here, when I connect both the ground and 5 volts, this guy is always 5 volt. This will be high resistor, this will be low resistor. So this is always treated as a 1. So what happened? Blank means always you get a chip, all 1, 1, 1, 1, 1, 1. When you get a chip from the customer, first chip, a ROM chip, all the data will be 1, 1, 1, 1, 1. You can change it as you wish using a programmer. But once you change it, you cannot get the fuse back. Then they come out with a technology called erasable programmable ROM. How do they erase it? They take the chip. There's a top, there's a hole. You pass a UV ray. Once you pass the UV ray, the fuse will come back. For that only they use the chip. What do you call? Floating gate MOSFET, FG MOSFET. They use here. Then people thought this they called as a EEPROM. They call EEPROM. Then they thought, how do I erase it electrically? Then there's a chip called electrically erasable PROM. EEPROM. One problem with the EEPROM is, if let's say I have a chip of 1,000 bytes. I have a chip of 1,000 bytes. 0 to 99. 99. I have to erase line by line. It takes very long time. Also, if I have 1 million, 1 MB, then it takes very long time. That time, two Japanese scientists found a mechanism. How do they erase block by block? Instead of line erasing, they do block erasing. That chip called flash. Understand? Please understand one important thing you understand. These are all actually ROM. Actually ROM. They have an address. They have a read and you get data. These are all ROM, non-volatile. But this is what your tri-state. You're going to read it. But how do I change the data? In the ROM you cannot change. The ROM, no change. PROM, one-time change. That's why they call this. They also call this the OTP ROM. Then EEPROM, you can erase and programmable. Erase and program, but this is a UV erase. Then they come out electrically erasable PROM. This is electrically erasable. But line wise, line by line. Then they come out with the called flash. That is called block erasable. So that is called block flash. That's actually called block EEPROM. That means that I erase block by block. So erase will become faster. But in the flash system, there are two types. That's not, these are all, I'm going to explain these are all later, not now. After we discuss about the embedded system programming, I will discuss these are all in one class thoroughly, all about memories. You have to understand about all about, even in the RAM itself, there are two types. One is called SRAM, another is called DRAM. In DRAM itself, there are so many types. SDRAM, DDR. Then DDR itself, so many types. DDR1, like this DDR4 and all. That's what today they use everywhere. So we should know that all of them. What are these things? So please understand. So don't worry about now how they have done here is they have few connections here with a chip connected to your PC, laptop. The laptop, you will have a file which will say that each line what data have to come. You send it. That is what we call download. You download the program is a thing. That means that on the RAM, you change the data. But once you change it, the data will be permanently there. Even power is not there. That is a concept of ROM. Okay. If you have any, maybe don't worry about the other one, but understand that if I have a flash, I can change the data through the laptop. That means that if you write a program in your PC, laptop, you compile it, that can be downloaded to your chip. That is possible. Okay, but that what you're doing is making the every bit as a 1 or 0. That's all. Once you make it, it will be permanently there. If you remove the power also. That's why they call this a non-volatile. But this is called programming. We don't call this as a writing. The RAM is called read-write memory. Understand now? So if any doubt, you can ask me now. So there are 4 types. 5 types we discussed. Mask RAM. You cannot change. That's why they call mask. Then OTP RAM. Or we call PROM. One-time programmable. Other one is EEPROM, EEPROM. This is UVEPROM. Then we call electrically erasable PROM. Then flash. And there are 2 types of flash that we'll discuss. Let's call NOR flash and NAND flash. Let us not worry about now. You have to understand only about ROM now. Don't worry about all this type of ROMs. Okay, this we will discuss about later. But why I have to tell you is that I tell you that ROM is a read-only memory. Then you will ask, how do I write it? That's why I'm explaining you that how can you write it? You are not writing. You are actually using a special method to change the data. That's it. You are actually not writing. There is no write signal. There is no write signal. Please understand. This guy can only read. Using your microprocessor, you cannot write into the ROM. Please understand. So if you have any doubt, you can ask me now. Then I'll start explaining about what is the difference between RAM and RWM. I'll explain to you now. But before that, I want you to know this. If you have any doubt on ROM, ROM simply understand. You have an address line to select location. You have a read to read the data. And the data is called, the data will come here, 8 bits. That's it. You cannot write. But this is non-volatile. Even I explained to you that in the RAM, the moment you remove the power, the data becomes X. Don't care. But here you get the data. The data will be permanently there, even if you remove the power. That is the advantage of ROM. If you have any doubt, you can ask me now. Now, let me explain to you one more important factor. The important factor is, what is the memory? These memories are the one which remembers. So initial days, people use magnetic tape. The magnetic tape will be like this. So there'll be a small head. The head will read or write the data. This is called read-write head. So the tape will be like this. Top, they'll be full of magnets. By writing or reading, I do the magnetizing or demagnetizing. That's why I do that. They have the ferrite material for it. We can able to magnetize or demagnetize it. Once it magnetizes, once I'm reading, it gives me 1. Otherwise, it will be 0. People use the tape to store it. But the problem is, let us assume that I store about 1000 bytes. And the tape beginning, I have a location 0. At the tape end, I have location 1000. Let us assume. I am at 0. Now I want to read from 999. What should I do? I have to fast forward from 0 to 999. It takes time. Same way, if I'm in 500, I have to do fast forward, easy. Let us say I'm at 800. I'm at 800. I want to go to, I want to read from 500. Then I have to do rewind. But if I ask you one question, I want to go to 900. How much time it will take? Nobody can tell you, because if I'm in 900 itself, it will take no time. If I'm in 800, it will take, if I'm in 800, it will take some time. If I'm at 0, it will take very long time. You understand? So I have to tell you that where I am. Then we can tell you how much time it will take. This is called sequential access memory, or called SAM. So in memory, we call SAM, sequential access memory. This is tape. The same way, they make it a little bit faster. That is called disk. But disk also, if you are here, to take it to this place, it takes some time. You cannot do that. It will take some time. But what the engineers want is like this. I have a memory. Maybe location at 0 or location at 1000. If I say that any location, 500, I should get data same time. Irrespective of location 0 or 1000, the time should be same. See here the time will vary. Here the time vary. That depends on where you are, where you are accessing, and so many things. If you are at 500, if you are accessing 555, it takes only 55, so much of less. If you are at 0, you want to read at 1000, it takes very long time. So in the tape or disk, you cannot predict how much time it will take. But engineers don't want that. Engineers are looking for a memory where they are looking for. So they call that as a random access memory. So why they call random? Let us say I ask now 0. If I get the time, if I get it on 1 microsecond, then if I give 200, I should get same 1 microsecond. If I give 500, I should get same 1 microsecond. I give 800, I should get same 1 microsecond. I get 1000, I get same 1 microsecond. See that? If I change if I access any location, if I may be asking 1000, next time asking 0, I should get same time. The time, this is called access time. Why we call this access time is accessing a data. You are accessing the data. So what the engineers want was, they were trying to invent a ROM. But what they first found was read-write memory. That is what your D flip-flop, 8-bit D flip-flop. They found it. This is actually read-write memory. I can do read as well as I can do write. But unfortunately, like you know that the story, Columbus, who was trying to find India to a sea route. He landed because of wind, the wrong route. He landed some other place, somewhere in the west. And he called it India. Then that's why history called this that is west of Britain. They called it West Indies. But actually it's not West Indies. There is nothing called West Indies and East Indies. This is absolutely wrong. And British are ruled both the places. They have called that as a West Indies. That is a mistake of somebody. There's only one India in the world. There's only one India in the world. There's nothing called East India or West India. That is not there. That was created. See that how they cover up the mistake. Who did a mistake? Columbus did a mistake of finding a wrong land as a India. And he called as I found India. And the British called that as a West India. Okay. So that's actually, it's not true. There is no relation between them and us. But the same way here, without knowing that a ROM is going to come, that is also a random access. There are two types of memories. There are two types of memories. One is called RWM, another one is ROM. Both are random access memory. But since when they invented the RWM, this was not invented. The engineers at Eureka, we found the ROM out of curiosity. So they called this a RAM. Please understand, there are two types of RAM. This is RWM. For example, you should know this because you are an engineer. You are not a common man. In your laptop, everywhere, you say that I have 1 GB RAM, 1 GB RAM. And I have a 8 GB RAM. These are not actually RAM. The moment you ask, if somebody asks you the expansion of the RAM, the college, data book, everywhere, we have been told to tell you that this is random access memory. See that? Because of all the books or written as a RAM is a random access memory. See, please understand that is random access memory only. I'm not telling that it's not a random access memory, but there are two types of random access memory. ROM is also a random access memory. So this is supposed to be called RWM. Because of a mistake, we call this a RAM. You understand now? So, please understand, there is nothing called RAM. This is actually RWM. Okay, but every book, every convention, they start writing as a RAM. We are writing, but it's a random access only. That is not fault, but this is random access. And in the random access, there are two types. ROM is also random access. Okay, RAM is also. Here is a trick. I'm confusing you, but don't forget it now. I told you so many types. ROM having a PROM, EEPROM, 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 and flash. And flash, I told there are two types. One is called NOR flash and NAND flash. Unfortunately, the NAND flash is a SAM. The NAND flash is the one used in your SD card, pen drive, SSD, hard disk. All are using a NAND flash, which is coming under ROM, but it is not coming under RAM. Please don't get confused. This NAND flash is a sequence. I'll explain to you later when we are discussing about all about memories. I discuss about RAM is having SRAM, DRAM. What is the difference? SRAM uses D flip-flop. DRAM uses capacitor. DRAM uses capacitor. SRAM uses D flip-flop because it saves a lot of space. That's why we are using. Let us say in your laptop or your mobile phone, you say I have a 4G RAM. The RAM is nothing but a DRAM, not SRAM. We don't use it. We use SRAM only as a cache memory. We will explain all these things later. I'm giving you the idea of what is what. So you should know that as an engineer, the beginner, you should know all these things. But we will explain these things in depth once you have done a embedded system programming thoroughly. You beginner level, you finish it thoroughly. I'll explain to you all these things to you. So now I'll explain to you the one more important thing, how the whole things are getting used. I have a microprocessor. Okay, the microprocessor reads a program from ROM. We will discuss about this in microprocessor, but I'll give you the idea of what are all we are used. And microprocessor use a RAM to store your, see, let's say I write a program, char x comma y, sorry, int x comma y, x is equal to 10, y is equal to x multiplied by 10. You write a program. This get compiled, you get assembly language. Then you get machine language. This is getting stored here. That is your program. But the x and y are stored here. Because you are writing. If the x and y are in the ROM, you cannot write. The x and y are in the RAM. So, microprocessor uses a RAM. Then, what we have? We have a latch with only output. I don't read it back. This is called output. And I have a tri-state, which takes only input. This is called input. Or together we call this as a input-output. IO. No. Why I'm telling you is that if you understand thoroughly the working principle of latch, if you understand the working principle of this one, tri-state logic, and you understand ROM and RAM, enough. But actually, the microprocessor will select ROM, RAM, input, output by using combination logic. So essentially like this, I'm not trying to explain to you this. This is what all the things I put it inside a chip. This is called microcontroller. So I'm trying to give you the idea of why this one, what we discussed was very important. The last 8 sessions, if you watch it, I don't mind how many times you watch, 5 times or 10 times, watch it. And that's the reason I share the videos to you. Watch it n number of times and make sure that you thoroughly understand. This, once you understand, you will never forget. But only once. These concepts are very, very important. This, if you understand this, you will understand everything, VLSI or everything. This is all very important. So, please understand this microcontroller is the main component for your embedded system. This output is the one you connect the LEDs. And input is the one you are connecting the switches. So, microprocessor, ROM, RAM, latch, and the tri-state. And
sir,
yeah,
sir, ROM stores this assembly code as a file, right? As a
no. Sorry. ROM never stores assembly code. ROM stores only machine code, binary code. It stores only 10110011, 11001111. It does not store machine code. Please.
Sir, actually, ROM and RAM in day-to-day life we are using ROM and RAM. Is this and that are both of them are same or different?
Same. Yeah, same. Every system, whenever you use microprocessor, whether it's a PC or laptop or your embedded system or your what do you call mobile phone, everywhere we use. If you use microprocessor, ROM is must and RAM is must.
So we are saving files in our laptop, right? So we are saving those files in ROMs, right?
No. That is different. No, that is different. That is called storage. We'll explain about later storage. There's something called storage is different. That is called hard disk or SSD. That is different. Your this one, what do you call? SD card. Flash, sorry, pen drive, SSD, HDD. These are all different. Okay, don't get confused.
Okay.
That permanent memory, we don't call them memory. We call them storage. These are called memory, which is connected to the microprocessor directly. Those are going via controllers. We will discuss about later. That we will discuss about the controller session.
Only zeros and ones are stored in ROM, right? Only
yeah. Nothing else. It's all only zeros and ones. Nothing else. Okay. So please understand, your embedded system basics is you are using microcontroller. Microcontroller is using microprocessor plus ROM, RAM, and latch and tri-state. Okay. Your ROM uses the combination logic, sequential logic. Your RAM uses the combination logic, sequential logic, and tri-state logic. They are same, nothing else. Understand? But inside the microprocessor uses same thing. Inside microprocessor, combination logic, sequential logic, tri-state logic, which we will discuss later sometime. When we get time, I'll discuss about microprocessor inside. Or you go and watch the microprocessor videos. Now you will understand thoroughly. Next week onwards, we're going to discuss about electrical and electronics. It's very important. Never miss it. Next week's session, never miss it. This is a very, very important electrical and electronics. Okay, so please, before I wind up, I'll give you the idea. Understand, the switch is important for your switch is important for digital electronics. The moment I say digital electronics is switch, but controlled by a voltage, controlled by electricity. And this digital electronics, we put the gates, logic gates, and logic functions, combination logic, sequential logic, and tri-state logic. And the application of them is a ROM, RAM components. These are all done. Digital electronics. And we have a separate session called microprocessors. There we will understand about microprocessors. Okay, is it clear? So if this path, the eight sessions, what we discuss in the digital electronics is very important. Okay, that will give you the good idea about how internally everything works. If you ask me the thing, if you say that you are ready, you watch the videos, and if you are ready, I will share this one. What do you call it? Self-assessment questions. Okay, then you can take it. Now only I'm going to share based on request. Okay, then if you have any doubt, you can ask me now. Or we wind up session. That's with this digital electronics is over. We started with what is digital electronics and what is the gates. Then what is combination sequential tri-state logic, ROM and RAM. With that, our session is over now. And next week, we are going to discuss about starting with electrical Monday. Please make sure that you attend that. That's very important. Okay, then let's wind up now. Stop the recording.